4 minutes, no lithium, and a battery designed to help stabilize one of the largest electrical grids in the world. On paper, it sounds like the kind of breakthrough that could weaken the battery industry's dependence on lithium almost overnight. There is only one problem. Those claims do not appear to belong to the same battery. The sodium-ion battery is real. The rapid charging battery is also real, but they are two different products, built with different chemistries for different purposes. Gotion High-Tech has introduced a sodium-ion battery platform that includes a grid storage cell designed for long operating life and extremely low temperatures. Separately, the company has demonstrated a battery capable of charging from 10 to 80% in 4.9 minutes. That second battery, however, uses lithium iron phosphate, which means it is neither lithium-free nor part of Gotion's sodium storage system. A third development added even more confusion: a fast-charging sodium metal study that was widely discussed alongside the Gotion announcement. Despite coming from a different research team, and although the Chinese Academy of Sciences was repeatedly associated with the story, no verified announcement showed Gotion and CAS jointly unveiling a single battery that combined all of these features. What emerged online was therefore not a fabricated technology, but a composite one. A real sodium storage battery, a real fast-charging lithium battery, and a separate academic study merged into one unusually convenient headline. To understand why that happened and what China has actually built, each part of the claim has to be separated. If China had really combined all of these capabilities in a single battery, it would raise an obvious question: had the United States and Europe already fallen behind? But before making that comparison, there was a more basic problem. The battery first had to exist as described. The first clue is hidden in Gotion's own product lineup. Nascent was not one battery with a single set of specifications, but a family of sodium-ion products designed for very different jobs. One version reached a claimed energy density of 261 watt-hours per kilogram, which sounds unusually high for sodium-ion technology. But that cell was aimed at lightweight vehicles and drones, not grid storage. The version intended for stationary storage was a separate 180 amp-hour cell, which Gotion said could survive more than 20,000 cycles and continue operating in extreme cold. Those are meaningful claims. Neither of them includes 4-minute charging. That number came from another Gotion product entirely, its 5th-generation lithium iron phosphate battery, which the company said could charge from 10 to 80% in 4.9 minutes. The speed was real, the chemistry was different. It was still a lithium battery. Then came a third piece of the story, a sodium metal research paper reporting strong performance at very high charging rates. But that work was produced by researchers affiliated with Southeast University, Hainan Battery, and Yangzhou University. It was not a Gotion product, and the published affiliations did not identify the Chinese Academy of Sciences as its developer. The supposed Gotion-CAS partnership is similarly difficult to verify. Gotion has documented academic collaborations, including work with Fudan University, but no reviewed announcement showed Gotion and CAS jointly unveiling a single sodium battery that combined 4-minute charging, grid-scale storage, and zero lithium. There was also a question of timing. Nascent was publicly launched in May 2026, but Gotion said large-scale production of the storage version was planned for the 4th quarter. A launch is not mass production, and mass production is not the same as deployment across the grid. So the headline was built from several genuine advances: one sodium-ion platform, one fast-charging lithium battery, and one separate sodium metal study. Each was real on its own. The breakthrough described online appeared only after they were combined. But correcting the headline leaves a more important question. Why is China investing so heavily in sodium if lithium batteries are already cheaper, more mature, and better suited to most electric vehicles? The answer is that sodium does not need to defeat lithium everywhere. It only needs to work in places where lithium's main advantage, high energy density, matters less. A battery installed beside a power station does not need to be light enough to carry inside a car. For grid storage, cost, operating life, low temperature performance, and access to raw materials can matter more than weight. Sodium is widely available, geographically dispersed, and less exposed to the same mineral bottlenecks that shape the lithium supply chain. In that role, it is not a replacement for lithium, so much as a second line of defense. Gotion's own strategy reflects this. The company is still investing in lithium iron phosphate, nickel-based cells, solid-state systems, and other lithium-dependent technologies. Sodium is one part of a wider portfolio, not a decision to abandon the chemistry that still supports most of its business. And Gotion is not making this bet alone. It remains a relatively small global battery supplier compared with CATL, which has already entered a 60 gigawatt-hour sodium storage agreement with Hyperstrong. The scale of that deal suggests that sodium is moving beyond isolated laboratory programs and into long-term industrial planning. China's advantage lies in how quickly that planning can become a market. Between 2025 and 2027, national policy encouraged power companies to expand the use of sodium-ion batteries in energy storage stations. That creates pilot projects. Pilot projects create orders. Orders give manufacturers the volume needed to lower costs and improve production. In other words, the technology does not have to reach perfect maturity before the market begins to form around it. There is also a second concentration problem, this time in the story rather than the supply chain. A rapid-charging lithium battery, a sodium-ion storage platform, and a sodium metal research paper were easier to understand once they became one breakthrough. But that simplification hides the real strategy. China is not waiting for a single chemistry to win. It is building several options at the same time, so that no single mineral, supplier, or technical failure can block the wider system. And once the story becomes a portfolio rather than a product, the decisive question is no longer which battery is best, but who controls the industrial structure capable of manufacturing all of them. Chemistry explains what a battery can do. It does not explain whether a company can finance it, manufacture it, or persuade governments to let the factory be built. Gotion's ownership structure makes that distinction clear. In 2020, Volkswagen announced an investment of roughly 1 billion euros for a 26% stake, making it Gotion's largest shareholder. But the deal did not give Volkswagen control. A voting arrangement kept Volkswagen's influence below that of the founding shareholders, while Li Zhen remained Gotion's ultimate controller. Volkswagen had gained access to one of China's major battery manufacturers, but the strategic center of the company remained in China. That difference between ownership and control appears again in Gotion's public numbers. Corporate materials have said that the company regularly invests more than 10% of annual revenue in research and employs over 7,000 R&D personnel. Its audited 2025 report, however, recorded research spending equal to 7.47% of revenue and listed 4,358 R&D employees. The discrepancy does not, by itself, prove misconduct. The figures may use different reporting periods or definitions, but it does show why promotional claims and audited disclosures are not interchangeable. And scale did not remove the financial pressure. Gotion generated 45.07 billion yuan in revenue during 2025 and reported 2.38 billion yuan in attributable profit. Yet in the first quarter of 2026, attributable profit fell by more than 79% from a year earlier, even as the company continued investing in new factories, new chemistries, and international expansion. The clearest example was in Michigan. In 2022, Gotion announced a battery materials project worth approximately $2.4 billion, which was expected to create 2,350 jobs. Instead, the proposal became entangled in local opposition, national security concerns, and a broader political dispute over Chinese investment in the United States. By October 2025, Michigan officials said the project had been abandoned. In January 2026, the state attorney general sought the return of $23.7 million. Gotion rejected that version of events, later sued Green Township, and described the state's claim as utterly false. The science inside the battery had not changed. The environment around it had. That is the part of battery competition that specifications cannot capture. A cell may perform well in a laboratory, yet still fail in a boardroom, at a border, or before the first factory wall is built. The decisive advantage is not simply having the best chemistry, but controlling an industrial system that can continue developing several chemistries despite financial pressure, political resistance, and shifting supply chains. So, after separating the claims, what has China actually built? The 4-minute charging figure belonged to a lithium iron phosphate battery. The lithium-free claim belonged to Goshen's sodium-ion platform, and the high-rate sodium metal research came from another group of institutions. The single breakthrough disappears once the pieces are placed back in their original context. What remains is a broader industrial strategy. Sodium does not need to replace lithium in every electric car to become useful. A grid battery sits on a concrete foundation. It does not need to be light enough to carry beneath a vehicle. In stationary storage, a heavier battery can still be competitive if it lasts longer, works in colder conditions, and depends on materials that are easier to source. Lithium will continue to dominate many applications because its supply chain is mature, its energy density is higher, and manufacturers already know how to produce it at enormous scale. But relying on one chemistry also creates exposure to mineral prices. This is why Goshen is not choosing between lithium and sodium. It is continuing to develop lithium-based cells while adding sodium, solid-state, and hybrid systems around them. Different batteries address different constraints, and the portfolio becomes more valuable than any individual product. That may be the more important shift taking place in China's battery industry. The objective is not to discover one perfect cell that makes every other chemistry obsolete. It is to build enough research, manufacturing capacity, and domestic demand to commercialize several alternatives at the same time. If lithium prices rise, sodium becomes more attractive. If sodium cannot meet the energy density requirement, lithium remains available. If one technology stalls in the laboratory, another can continue toward production. The headline promised a sudden break from lithium. The evidence points to something slower, less cinematic, and potentially more consequential. An industrial system designed to avoid depending on a single technical answer. The battery China is racing to build is not one battery at all.